So I am your grading teacher. So whatever Tuesday module you have, which for you is this right now, Lynn's 10, 12. So when you go dump it in the basket or dump something in the basket, Lynn's 10 and 12. Now on. Okay? Check your schedule. Make sure you got pre-calc all 4 days. Most of you already have that. I'm not too worried about that at all, but good there. Okay? If you haven't taken the test that we took last week, I was talking with B.B. Foster last night. Yeah, somebody came in after school yesterday and took their test because they were saying, did you have a test already in second semester? Yeah, for me, we did it. So if you haven't taken your test yet, get it taken. I hope to have them corrected tonight. However, probably not. We'll add that one. Okay. So we are in your notes. You don't have to write all this down. I just love this mathematical explanation. So, new chapter. What do we got to look forward to in this one? In this chapter, we will shift our emphasis more towards theory and proof. Exploring where the properties of these special functions, the trig functions, lead us, often with no immediate concern for the real world relevance at all. Meaning, you're going to ask me, where am I going to use this? And I'm going to say, I don't care, because this stuff is fun. Okay? This stuff is fun. It'll get to it. You'll see where we're going in the end, but right now, we're just having fun with all these trig functions. We hope in the process to give you an appreciation for the rich and intricate tapestry of interlocking patterns that can be woven from the 6 basic trigonometric functions. I'm telling you, this is some high class. Like, pull the pants up, roll them up, then yank them up, then put your barn boots on because your boots are going to be full from all of this BS that we're talking about. But it's not really. It's just good words. Okay? Woven from the 6 basic trigonometric patterns that will make an even greater beauty later on when you can view them through the lens of calculus. All right, let's do this. All right, so 6 trig identities. You've already known this. You know that cosine is equal to cosine, you know that sine is equal to sine. You know, or you should know by now, that tangent is sine over cosine. Cosecant is 1 over sine. Cotangent, 1 or cosine over sine, or 1 over tangent. And secant is 1 over cosine. And then you got the big one, the hammer. Sine squared plus cosine squared equals 1. Now, if you're looking upon the sheet that I just handed out to you, purple, okay, that is number 7. Number 7 is the hammer. And then it also goes on to say on the hammer that cosine squared is also equal to 1 minus sine squared. I can't remember. Did we use t's on there? I think we used t's on there because then it was easier and you didn't have to keep punching the theta key. We also went on to say that sine squared is 1 minus cosine squared. Okay. So those are all the same function, or all the same identity. Those are all of those 26 are identities that we're going to use at some point. Okay? So number 7, the hammer, just happens to have 3 different versions of it. It depends on how you're going to use it. So we got all those in our straw in our closet. Okay? So what happens if we take the hammer, sine squared plus cosine squared equals 1, and we divide everything, because when we're dividing both sides, we're really dividing everything by sine squared. With me? Side note, this is where you should be taking notes we be developing more identities on our sheet. First one, sine squared divided by sine squared. What's this one? Print says 1. Do we agree with 1? Anything divided by itself is 1? Yeah, but then this one, cosine squared divided by sine squared. What's that? Is what? No, inverse tangent finds me an angle. Close. Cotangent squared. Yeah, cotangent squared because they're both squared. What's that one? Fill up. Squared. Which on your sheet is number 10. She's not lying. Yeah. Love it. What happens if we divide everything by cosine squared? Sine squared over cosine squared. Tangent squared. Yes. Cosine squared divided by cosine squared. That's just going to be 1. 1 over cosine squared. Secant squared. Yep. It would have just been secant if it was 1 over cosine. That one, I think, is number 11. Yes? And then, Rose, we could also say that secant squared minus tangent squared is 1. We could also say that tangent squared is secant squared minus 1. You know what I mean? So we could offshoot all of those. Up here, we could say cosecant squared minus cotangent squared is 1. We could say that cotangent squared is cosecant squared minus 1. And all those other offshoots, just like in number 7, which you have so expertly boxed, the different offshoots. Okay? All right? Good times. So, what's going to happen here now is we are going to give you these funky looking trig statements. And all we're going to say is simplify. Okay? And you're going to simplify and use 1 through 11 right now as much as you possibly can until you can't use anything anymore, and then it's simplified. Okay? So, if I'm looking at my purple sheet, secant of negative x, give me a number as to which one it is. Number 4. So secant of negative x would simplify to be what? Secant of just x, right? Secant of x would simplify to be what? One over cosine of x. Right? Okay. Cosine of negative x. Which number? 1 simplifies to be 1 over cosine of x times cosine of x. Just gives me 1. Could have we done this a different way? Yeah. What's another way of saying secant of negative x? Couldn't that just be 1 over cosine of negative x times cosine of negative x? Would give me cosine of negative x over cosine of negative x, which would give me 1. Right? There are multiple ways that you could do all of these problems. Okay? Not on you to do it one specific way. All on me to make sure you're doing it correct. Okay? So it's kind of like that Robert Frost poem, 2 paths diverged in the woods. Well, but now there's like 18 different paths that could diverge, but you're all going to end up. Okay? Secant squared minus tangent squared. Well, according to number 11, secant squared here is tangent squared plus 1. Tangent squared plus 1 minus tangent squared becomes 1. Okay. You try those two. So cosine is cosine, really can't do anything with that, but tangent is sine over cosine. And then those two cancel each other out, so then that just leaves me with sine of x. Secant is 1 over cosine. Cotangent is cosine over sine. The cosines cancel each other out, leaving me with 1 over sine, which normally you would say, well, yeah, Lance, I got it down to 1 trig function. Yeah, you did. However, we like it better as just cosecant. Okay? So if you gave me 1 over sine there, I would mark it wrong. Next week's one. Formative next week, Tuesday. It's circle. Test. Following. Okay? All right. Oh, snap. Love it. Love it. Which one do you want to do first? 5? Okay. All right. Ready? Sine is sine, right? Let's cosecant. 1 over sine. Inside parentheses. Can I combine them? As written, just like that. Can I combine them? No. What do I have to do in order to combine fractions? Starts with a C, ends with common denominator. Gotta have a common denominator, right? Okay. So if I'm looking just at this, that would be 1 over sine of theta minus sine squared of theta over sine of theta. Which then that is going to become 1 minus sine squared of theta over sine of theta. That can then be multiplied by the sine of theta outside the parentheses and becomes what? One minus sine squared theta. One minus sine squared of theta is cosine squared of theta. One minus cosine squared. Anytime that you see a squared, you should think it's got to be some kind of an identity. 1 minus cosine squared theta. X, sorry. 1 minus cosine squared of x is just sine squared of x. No? Cosecant is sine squared times 1 over sine is just sine squared divided by sine. Just sine. Huh? You try those two. Cosecant. What is cosecant? 1 over sine. Okay. So this is 1 over sine of theta. What is secant? 1 over cosine. So then that's over 1 over cosine. And then our favorite 3 words when we're dividing fractions. Keep, change, flip. So we're going to keep the 1 over the sine, and we're going to say 1 over sine times, then, oops, I put 2 times, times cosine over 1 would get me cosine over sine, which is cotangent of theta. Okay. Cosine squared times the quantity tangent squared plus 1. Tangent squared plus 1. Squared means it's probably an identity. Oh, I like the tangent squared plus 1 as number 11 as just secant squared. What is secant squared? 1 over cosine squared. And then that's going to be times cosine squared of u. Cosine squared times 1 over cosine squared is 1. No. Everything goes 1. Is that you, Nadia? Nadia, you want to take that one?
No.
Slip through the cracks. Yeah. Yeah. Missed it yesterday when I was editing. Don't worry. Yeah, she did. She had to start. Yeah. That's why I had Nadia answer that question. All right, last one. Oh, snap. Here we go. Here we go. Here we go, Jim. No, it's what Tony Romo says on the CBS broadcast. Jim Nance is the color or play-by-play guy for him, and then after, he'll call Tony Romo. This is what's going to happen, and then Tony Romo will get all excited. Here we go, Jim. I said there's a naughty word on this slide. It starts with an F. Good news, you got it back. No. Did you just get it, Chris? So, what can I factor out of this? Can I? What's the first step in factoring? 3 letters. No? What? Greatest common factor. GCF. Always check to see if there is a GCF to factor out. Is there the same term in each of my 2 terms? Yay or nay? Yay. What do we factor out then? Sine of x. So this would become sine of x times what's left over? No? 1, right? Minus cosine squared. One minus cosine squared is sine squared. Yes, this is the hammer, part of number 7 right here. That becomes sine squared. Sine times sine squared. Sine to the 3rd or sine cubed of x. I think there's only one. Oh my gosh, there's 2. Can I fit them on there? Woo! Okay, do those 2. Yeah. What am I going to factor out number 10? Cosine squared? Love it. If I factor out a cosine squared, then I got cosine squared of theta times the quantity. 1 plus tangent. 1 plus tangent squared. Secant squared number 11, right? Even though it's tangent squared plus 1 in number 11, it's the same as 1 plus tangent. Okay? Secant squared is 1 over cosine squared. Cosine squared times 1 over cosine squared. 1. So that whole big, long, ugly looking thing right here, that line right there, that really is just 1. Right? Bottom one. Can I factor anything out? Can I factor anything out? What? Just a sign? What's left over? No. Yes, sine squared plus cosine squared. I figured I better not let you go on very much farther when you got to the plus after the 1. Sine squared plus cosine squared. That's just 1, right? That's the hammer. That's number 7, original. Okay? So then this is just 1. 1 times sine of x. Sine of x. Now, where we're going. So right now, we're learning how to go, let's say, in this direction. Okay? All right? And so then we're getting to the point where we're going to say that this is equal to sine of x, and we're going to say, prove it. That's what next week is all about. We're going to prove these trig identities. Okay? And you're going to have to show all of your steps. You don't get the luxury when we're proving next week to skip any steps or to do work in your head. Okay? I say that now because you should be showing all of your steps right now, because next week if you don't show your steps, you're not going to get all of the points that are coming to you, which means the following week when we take the test, you're not going to do well. Because I need to be able to see what you're thinking. So it needs to be on paper. Okay? All right? We're going to do this today, and we're going to add some more identities tomorrow. Then on Thursday and Friday, we're going to get into solving. So we're going to have equations, and then we're going to actually solve them first lap of the unit circle, based off of being able to factor and being able to, manipulate this a little. Okay? You have the ability now to do, so the packet that I handed out to you is all of the homeworks for this chapter, for this sections, 5.1 and 5.2. You can do front side first sheet right now, okay, if you want. That homework packet will be collected from all on the 6th of February.